So first we will see what are the various halobenzenes, and then we will talk about their positions, and then we will go about their reaction. Okay.
Yes, sir.
So this is your example of a halobenzene. So when it becomes di-substituted, so this position is called as ipso position.
Right.
So these two positions are called as ortho. These two positions are called as meta, while this position is an ortho. Para position. So I think we have seen this already. So now the question is, what about an halogen? Number one, an halogen, which can be chlorine, bromine or iodine, or in a very rare case scenario even fluorine, are ortho and para director. That means when you take a halobenzene, you can treat it with another halogen. What will happen? The incoming group will go to the ortho position or para position.
Yes, sir.
Okay, so in that the most major one would be the para-chlorobenzene, and the minor one will be ortho. So para isomer, ortho isomer. So this is minor, this is major.
Sir, கொஞ்சம் மேல போறீங்களா சார்? லாஸ்ட் பாயிண்ட். Yes, sir.
Done?
Yes, sir.
Okay. Now the question is, why the halogen attached to a benzene ring acts as a ortho and para director? Why it acts as an ortho and para director? Now the answer is very simple. First we have to look into the nature of the halogen. So when you take an halogen, we all know the halogen is an electron withdrawing group. What do you mean by withdrawing group? Because chlorine or any halogens are electronegative. So what do you mean by electronegative group? Electronegativity or electronegative group அப்படின்னா என்ன அர்த்தம் அப்படின்னா, very simple, it pulls a pair of electron towards itself. So if I say an electronegative group, what is the nature? It pulls electron.
Negative.
It pulls electron towards itself. What do you mean by pulling an electron? Through inductive effect. So through inductive effect, the electron will be pulled from the benzene towards the chlorine. Okay, so these are all the known points. But now we also need to look into what makes it to push the electrons towards the benzene. So when this electron gets into the benzene ring, you get something like this. Since the electron gone from the chlorine, there will be a positive charge at the chlorine, and the electron that got shifted to the ortho position again moves into the benzene ring through resonance.
Yes, sir.
So you can see in this second molecule, the chlorine releases electron via resonance effect.
Yes, sir.
Now the question is, among the two effects such as inductive effect and resonance effect, which is more stable? The answer is very well known, that resonance effect is a permanent effect than the inductive effect. So the predominance of resonance will be more than inductive effect. So what is the key word? The predominance. Resonance over inductive effects, hence it will act as an ortho and para director. Copy ma.
Sir, what is after resonance effect is a permanent effect? What is the
Then the inductive effect. Permanent effect. La.
Correct.
More stabilized, more permanent. So now you are clear that halogens are electron releasing group, then it is an electron withdrawing group. And they are electron releasing group because of what reason? Predominance of resonance effect over inductive effect. So very clearly you can say that. Copy Dama?
Yes, sir.
So very clearly you can say that halogens or X halides are electron releasing group.
Yes.
So why they are acting as an electron releasing group? I think I've already explained. Predominance of resonance over inductive effect. So it is a perfect ortho and para director.
Yes, sir.
Now we are getting into the next part of the chapter, that is, if the chlorobenzene is going to react with alcohol, for example, I'm going to take chlorobenzene and treat with aqueous KOH. You can very clearly see there is no reaction happening. But
yes, sir.
If you treat this with same NaOH or KOH, whatever, at 623 Kelvin, 10 atmospheric pressure, you can see that chlorine will be replaced by OK.
Oh, okay.
So this is called as chlorobenzene. This is potassium phenoxide. So now you treat this with H3O plus. So minus KOH will be removed and you'll get OH, that is phenol.
Yes. Oh, okay. Okay.
Now the question is, I'll write one more point. Instead of 110 atmosphere, it can also be 300 atmospheric pressure, depending on the the conditions. The latest conditions may be with a lesser atmospheric pressure, but the original condition was 300 atmospheric pressure.
Yes.
To bring this condition itself, it's very difficult. So we can very clearly say that when chlorobenzene is treated with KOH at 623 Kelvin and 300 atmospheric pressure, it is the CCl bond is easy to break, or you can replace the CCl bond in chlorobenzene. The question is, why it takes a drastic condition? The reaction takes place at drastic condition. So drastic condition, reaction happens. So at a mild condition, no reaction.
Yes.
Now the question is, why a drastic condition happens while at a normal condition it doesn't? Very simple. We can simply conclude that the chlorobenzene, please make a note.
Yes, sir.
Chlorobenzene do not undergo does not undergo nucleophilic substitution reactions. Doesn't undergo substitution nucleophilic reaction. Now the question is, why it doesn't undergo? So let us see some reasons. So number one, as I said before, it's very difficult to break the CCl bond, right? So if you take chlorobenzene, as we have already seen, the chlorobenzene will involve in resonance, right?
Yes, sir.
So if you look at the resonance, in most of the case, the CCl bond will be a double bond. So you check in all the bonds, if you check, most of the time the CCl bond is a double bond. And it goes on. So in a simple language, you can say that it has a partial double bond character due to
resonance.
Very good. So this is one of the reasons. Let us see another reason. You compare chlorobenzene and then you compare cyclohexyl chloride. So this is sp2 carbon, this is sp3 carbon, correct, Amma?
Yes, sir.
So we know that sp2 carbon is more electronegative than sp3 carbon. sp2 is more electronegative than sp3 carbon. அப்ப என்ன ஆகும்? A nucleophile attack takes place with much difficulty.
Yes, sir.
In a chlorobenzene, because chlorobenzene is an electronegative carbon. So this is one of the reasons.
Yes.
Third reason, let us assume SN1 reaction. So what is the condition for SN1 reaction? It should form a stable carbocation.
Correct. Stable
So
carbon.
it should form a phenyl carbocation. Remember, phenyl carbocation is hypothetical. It can never exist. So its existence is never known.
Yes.
So since it cannot form phenyl carbocation, SN1 is not possible. Number 4, SN2 reaction. So what do you mean by SN2 reaction? You have pi clouds here, which is electronegative, and if you try to bring a nucleophile and attack from the rear side, it's not possible. So you can write the rear side attack of nucleophile isn't possible. What is the reason? Due to repulsion caused by pi clouds.
Likewise.
இந்த 4 பாயிண்ட்டுமே எழுதணுமா? Chlorobenzene doesn't undergo nucleophilic reaction. Make a note ma.
Yes.
So chlorobenzene will undergo only
Substitution reaction.
electrophilic substitution,
Electrophilic.
because we saw nucleophilic is not possible. Now the question is, chlorobenzene undergoes electrophilic substitution reaction. Nucleophilic impossible, we already saw. Why it undergoes electrophilic substitution reaction? We have to look into that reason. Very simple. What is an electrophile? So this is a chlorobenzene, and we know it's an orthopara director.
Yes, sir.
That means the electron is abundant in the ortho and para position. So the electron will come and attack the electrophile. Thereby what will happen? So we already had hydrogen here, and the new group is E. Correct?
So the bond got broken and became hydrogen.
So there is a positive charge here. Okay, so there is a positive charge. Now what will happen to the positive charge? Because the bond was common for both the ipso carbon and the ortho position. Now the bond is at the ortho position. Now this will start moving towards the positively charged carbon.
Yes, sir.
So nothing will happen to the halogen, nothing will happen to the hydrogen, or nothing will happen to the electrophile. So simple movement of the pi cloud over here. Again this will shift here. Again you can very clearly see that in the last position the hydrogen will give its electron and goes out as proton.
Yes, sir.
So you get a ortho or para position electrophilic substitution reaction. So the electrophile compared to nucleophile, a nucleophile is a negatively charged species, while the electrophile is a positively charged species. And we know there is a want of positively charged ion because their electrons are very much dense in the ortho and para positions, which is understood from the resonance, isn't it? If you look at the resonance itself, look at this position, it is more electronegative. This position also more electronegative. This position is also more electronegative. Since the electronegativity in the ortho and para positions are quite high, the incoming group called the so-called electrophile, which is positively charged, can easily attack ortho or para position only. Because of this reason, we can simply say that chlorobenzene undergoes electrophilic substitution reaction only, but not nucleophilic.
Yes, sure.
Electrophilic reactions possible. First we'll see them. So electrophilic reactions. This is your chlorobenzene. You treat it with Cl2 in presence of FeCl3. It can be an ortho or a para isomer.
Yes.
So if I do nitration to that, the nitro can go to the ortho position or para position. So you can even do sulfonation. And always sulfonation is a reversible reaction.
Yes.
Okay, so since it's a reversible reaction, here also you'll get two products.
Yes.
Similarly, it can also undergo nucleophilic substitution, electrophilic substitution called Friedel-Crafts reaction. So CH3Cl in presence of anhydrous AlCl3 you have two chlorobenzenes. One is ortho, another one is para. So similar to that, you can also have CH3COCl, anhydrous AlCl3 once again, where you will have same chlorobenzene. Either we will have COCH3 in the ortho position or COCH3 in the para position. So it can undergo all the 5 reactions. And the most important thing, which is major and which is minor.
Yes, sir.
So always this is major.
So is it always para portion which is major?
Yeah, most of the time, always. In some reactions it may vary. Other we'll see in the alcohols.
Yes, sir, completely.
Minor. Minor.
Okay.
Okay.
Yes.
So the reason why para is more possible than ortho. Any reason? Do you know the reason why?
So because para is more stable than.
That's the reason. Para is more stable. Why para is more stable? First of all, when you look into the dipole moment, the dipole moment is 0 for para isomer than the ortho isomer. Or you can even say it will be minimum. So when the dipole moment is not going to be very high, the molecule will not collide with each other. The two groups will collide with each other. So the collision is avoided. Thereby the stability is increased. So the angle strain or the nearby group strain is removed. So that is the reason when it is in the opposite direction there is no such problem. Another thing, you can even see that the molecule is symmetrically positioned.
Yes, sir, it's symmetric.
So the symmetry is maintained. So with all these reasons, you can see that the para isomers are majority when compared to the ortho isomer.
Yes.
Right? So now let us see how we are going to remove this partial double bond character and establish especially when you talk about the nucleophilic reaction. Okay, how are we going to make it react or to make it undergo a nucleophilic reaction is what we are going to see. Paklama?
Yes. Yes, sir.
For example, you take, again, these are all facts which are not given in the textbook. Okay, so when you talk about the reactions, These facts are not there in the textbooks. Let me write the reaction and then you can see. Okay. For example, you take
Yes, sir.
chlorobenzene with one nitro group in the para position.
Got it, sir.
Or you can see a chlorobenzene. I'll use a different color so that no.
Yes, sir.
So there are two nitro group, one in the ortho, another one in the para. Similarly, you take a chlorobenzene where the nitro group is going to be in the all the three positions. Not meta, or two ortho positions and meta position.
Oh, okay.
In meta position, nitro will not have effect. I will explain that later. Okay?
Yes, sir.
In meta position, it will not have any big effect, much effect. Let
Yes.
us not look into that. That's not a big deal. So for example, if you take a para position and if you treat it with NaOH, so first you're going to treat this with NaOH at 443 Kelvin, followed by H3O+.
Yes, sir.
Similarly, in this case, if you notice, the reaction is going to be much more less drastic. What do you mean by less drastic? The conditions are not going to be as more what you see in the other cases like the prior ones. For example, here it is NaOH at 368 Kelvin, and you need to do
Or less.
hydrolysis as usual. Similarly, when you take this particular case, you just warm the solution, that is trinitrochlorobenzene, with water. Just warm it with water, that's all. Now what will happen is the question.
So as you go like this, you have to like decrease the temperature.
Not I am decreasing. The reaction takes place at a much lower conditions without any difficulty.
Okay.
So மற்ற கேஸில் வந்துட்டு we have to introduce that condition, right?
Yes, sir.
இங்கே அந்த பிரச்சனை இங்கே வந்து what is the major problem is even at a mild condition the chlorobenzene is replaced. So easily the OH can be introduced is what I am saying. So இதில் OH, இதுலேயும் OH தான், மூணுமே phenol is under, I mean nucleophilic substitution reaction now. OH minus is actually replaced. But the question is, when a nitro group is going to be there, the reaction takes place at a what you can say, a milder condition, not even a drastic condition. 623 Kelvin, 300 atmosphere, it has gone down. And you should also look at the rate. This is the number textbook they didn't give. Write the rate of the reaction. So the rate of the reaction comparative paathomna, I'll write separately on the top. So the rates of the reactions. So first one it is 7 into 10 to the power 10. Second one it's 2.4 into 10 to the power 15. While the last one is too fast to measure and draw.
Sir, how do you measure the rate of reaction, sir?
Chemical kinetics padikkanuma. Rate of change in concentration with respect to time.
Okay.
So how fast the product is formed. with respect to time. How fast a reactant is diminishing with respect to time. Apdi.
Okay.
Now the question is, this effect, what you see here, is possible only if the nitro group is going to be in the para and ortho position. If it is going to be in a meta position, this will not work out.
Sir, what do you mean if it's too fast to measure?
Too fast to measure, the reaction is so quick that as soon as you add water and warm, the OH is getting replaced in the position of chlorine.
Okay.
Rate of the reaction வந்து ரொம்ப ஃபாஸ்ட்டாக இருக்குன்னா immediately it will happen 10 to the power 15 இந்த மாதிரி இருக்கும். பட் இதுக்கெல்லாம் பார்த்தீங்கன்னா when you at a normal room condition itself the reaction takes place without any difficulty. ஆனால் இந்த ரேட் வந்து உன்னால் மெஷரே பண்ண முடியாது. சுடுதண்ணி போட்டு கொதிக்க வச்சாலே it will give you product. That's what it says.
Yes, sir.
Done?
Yes, sir. Yes, sir.
Right. Now let us see the other things. So if a chlorobenzene is going to be having a nitro group in the para position, okay?
Yes.
So what will happen? What is the nature of nitro group? To pull the electron, because it's an electron withdrawing group. So என்ன பண்ணும், the electron will go here. So now what will happen? So positive charge. Again what will happen? This will come back over here. This will move here. So there is a shift in the electron only if the nitro is in the para position. Now let us see in the ortho position also. Okay?
Yes, sir.
So chloro, the electrons have come, so there is a positive charge. Again what will happen? So if the nitro is in the ortho and para position, in the mari resonance possibilities are there. Now let us introduce the same nitro in the meta position and see what is going to happen. Correct, Anna? My point is right?
Yes, sir. Yes, sir.
So we are just going to analyze enna agudhu appdi nama paaka porom. That's all, nothing more.
Okay.
So when I push it, what will happen? This will come to the ortho position. Correct?
Correct, sir.
And what have happened?
So no effect, sir.
Resonance and the nitrogen kitta electron pogathu.
So nothing is idume alla. Correct, sir.
So again it comes to the para position. It's skipping the nitro position, that is the meta position is being skipped. Alla gaunsteva, the nitro position it is being skipped. So the electron is not even going to nitro no more, then how do you expect it to undergo resonance? That is why when the nitro is in the ortho and para position, the reaction is very drastic.
Yes.
எல்லாத்துலேயும் பாசிட்டிவ் சார்ஜ் போட மறந்துடாதம்மா, நான் போட மறந்துட்டேன்.
Yes.
So it is made that the electron is never available when the nitro is in the meta position.
Beta.
About what do you mean? If I have a nitrobenzene like this, for example, இதே phenol போட்டு, if I'm going to have nitro here, I have to use the same condition, right? NaOH,
Yes.
623 Kelvin, same 300 atmospheric pressure.
Yeah.
Why?
Okay.
Because it has no effect. Nitro has no effect. Not phenol,
Yes, sir.
chlorobenzene.
Close here.
So the incoming group will be ONA, and if you put H3O plus, it becomes OH. Correct?
Yes.
So that's why I told you the effect is much more noticed only in ortho and para position, but if it is going to be in meta, it doesn't. Copy ma.
Yes.
Hope the
Yes,
board
sir.
is visible. Board terida?
Yeah. Very sir. So இப்போ தெரியல சார்.
ஒரே நிமிஷமா. Yeah, board தெரியும். இப்போ தெரியும். Okay?
தெரியும் சார்.
So now let us see how this goes. So first we have chlorobenzene, correct?
Correct sir.
So this is your aluminum chloride is your catalyst,
Yes.
and
Yes.
the N-propyl chloride is your nucleophile generator. So you'll get a primary carbocation. Now what will happen? 1,2 hydride shift will take place. So you'll get a secondary carbocation which is much more stable than the primary.
So it's CH3, CH2, CH3.
Exactly. So now what will happen?
Okay.
It goes on. So the final step would be நம்ம ரெண்டு பேரும் ஒரே ஏரியால இருந்தா கிளாஸ் கவனிச்சிட்டு இருக்கோமோ?
Yes sir. உங்களுக்கும் சவுண்ட் கேட்குது.
எனக்கும் அதே சவுண்டு தான் கேட்டுச்சு, உனக்கும் அதே சவுண்டு தான் கேட்டுச்சு. நீ மந்தோரி ஸ்ட்ரீட்ல தான் இருக்கியா வீடு?
ஆமா சார்.
ஓகே, எங்க இருக்கு வீடு உனக்கு ஆக்சுவலி?